All right, everybody, welcome back. First thing we're going to do to warm up today, fill in the blank unit circle. If you do not have this memorized by now, you need to. You need to know all the radian measurements and all the angle measurements and all the coordinates. It's just a pattern that's reoccurring, but some things to help us with that is the degree measurements I think we can do pretty easy, but the radians, how I like to think of it, because it's hard to know the radian measurements of all those angles, is I just start with these like pi, I'm going to get a black marker. I start with these pi over 6s, okay? So we know this first one is pi over 6, so that's like 30 degrees. And so every 30 degrees, we're forgetting about the 45 degree ones right now, but every 30 degrees, this would be 2 pi over 6, 3 pi over 6. So every 30 degrees, you're adding a pi over 6. So you can continue that down, and then how to know how to do these is you can reduce the fraction. So like 2 pi over 6 reduces to pi over 3. 4 pi over 6 reduces to 2 pi over 3. So that's how I kind of do mine with the unit circle, because I think that's a good way to not have to memorize it, but be able to come up with it whenever you need it. Like, same thing here is it's pi over 4, so you're just adding a pi over 4 every 45 degrees. And then we can reduce 2 pi over 4 becomes pi over 2. So the same thing with those 45s. If you know these first two right here, you can figure out any one in the triangle. It might take some time, but it's important to know where that comes from. So if you have a printer, you could print one off. I suggested that some students do it once a day. You got all the time in the world. If not, you can just copy one down and try to fill in the blank best you can. So pause the video and try that. We're just going to get like our basic sine and cosine graphs down. Okay, so we're just going to sketch a graph of sine of x and cosine of x. Keep in mind, what is the difference between graphing sine and cosine? So how we do these is we always draw, we're going to usually graph, like on the test, you're going to have to go from 0 to 2. You're going to have to do like 2 cycles on your test. So the way we do this is we go from -1 to 1. And then we say, okay, we know it's going to do 1 period. It's going to go through 1 cycle every 2 pi. So the important parts we're going to graph is we're going to go halfway. What's halfway between 2 pi and 0? Well, it's just pi. And what's halfway between pi and 0? Well, it's half a pi. So you're going to have to get good at that. What's halfway between pi and 2 pi? Well, it's 3 pi over 2. So when we're graphing sine, and the big question here is what is the difference? What was the difference when graphing those? Well, it's where they start. So sine always started at 0. And then at pi over 2, it went up to 1. At pi, it was back to 0. Then it goes to -1. And then back to 0. So you don't have to do every single point like we did in our investigations, explorations. You can just do the zeros, the maximums, and the minimums. So going backwards, this would be -pi, -pi over 2, and -3 pi over 2. And so it's going to follow that same way. So every pi over 2, it's going to switch from a maximum to a middle, back to a maximum, and back to our 0. And just knowing it's just going to do this wave the whole time. So the difference here between sine and cosine is for cosine, we're not starting at 0. So let's label this first 2 pi. Try to line it up with the top one. 3 pi over 2, pi over 2. -pi over 2, -pi, -3 pi over 2, and negative 2 pi. That's a 2, I swear. So the difference is cosine, if we go from negative 1 to 1, is cosine starts at 1. The x value starts at 1. And then each little interval here, it's doing this little different type of wave. So it starts at 1, but it's still following that same pattern of making that wave with a maximum of 1, minimum of negative 1. So the difference, the important answer here, difference between graphing sine and cosine, sine starts at 0, cosine starts at 1. So make a note of that somewhere in your notebook, because that's very important when we're graphing these. All right, so here we have general form of sine and cosine. So f of x, it's the same thing as y. G of x, same thing as y. If you see that, it's the same. But we have a sine b of x plus k. A cosine b of x plus k. So thinking back to our investigations, what did the a do to the graph of sine and cosine? Well, a is the amplitude. So it changed our graph from here to here. Or could be lower, like that. It changes how stretched or compressed that is. Sorry. So it changes how tall or short our graph is. It does not change the period. This period here would still be the same no matter what. So the b, this part was our b, changed the period. And our important thing there is the period equals 2 pi divided by b. So that equation we're going to need for graphing later. And then what does the k do? It's our vertical shift. Vertical shift. So that, if we had a line that looked like this, it could shift it up to look like that, where new center is higher or lower. So K is the vertical shift. So add that to your toolkit. This is the big idea. Everything we do from now on is just going to use these three things.